Hello everyone, this is the practice exam that you were given. It's question 1, A and B. So you're first of all given a bunch of data for the decomposition of hydrogen peroxide. You have time and concentration data, and you're told that it's a first order reaction. So right away we know our rate law equations for first order. So A equals A naught e to the minus KT, and then also broken down to find the straight line, you have ln A equals ln A naught minus KT. So if you plot ln A versus time, you end up with a straight line, the slope of which is minus k, which is rate constant, and your intercept, y-intercept, is ln A naught. So the first part of this question asks you to find the rate constant. So there are a couple different ways of doing this. Of course, if you had Excel right there, you can easily just plot this data. So you put in the time and then the concentration, but then find ln of the concentration for all those different times. Plot this out and find your slope, and it'll be the negative value. Of course, you're in the middle of an exam. For this particular one was in the exam hall. So in this case here, you can take either two sets of data. You know A naught is your t equals 0. So you have A data and T data for a variety of them. So take any set and solve for K. Of course, it's going to give you slight variations depending on which set you end up taking, which is fine. Or you can actually find the ln A versus T data for some of these and do a rise over run for two sets of them. Okay, so take 2 points, find like a pretend straight line between the two, and get your rise over run. So in the end, whichever way you decide to do it, let's say K is about 7.3 times 10 to the minus 4. Your units, you know this is first order, so this should be seconds to the minus 1. Let's try to ignore the screaming baby in the background sometimes. Sorry about that. Now, part 2. This case is asking you to do the concentration, or find the concentration of peroxide at 1600 seconds. So you know what your K is. You can do is easily just go ahead and find A using this equation, knowing the K that you calculated right above. Your time is 1600 seconds. A naught is 2.32 molar. That's straight out of the table. And if you do that, you are going to get a value, I know what your K is that you use, of approximately, what did I just get for that one? 0.72 molar. So that should also fit, if you go back in your table and just make sure it fits in with the temperature or the time and concentration values from before.